Hi there, let's deal again in our chemistry unit with properties of matter, with physical and chemical changes, and then talk about, we've already dealt with atoms, but what happens in a chemical change to the atoms in a reaction. So scientists classify things, and one thing they classify, of course, is matter. And they use physical and chemical properties to help classify matter. So let's get into and deal with those physical and chemical properties. Physical properties deal with the appearance of the substance and involve the change of state. And when you observe a physical property of a substance, usually you can reverse that change. So we can dissolve something, but we could reverse it and get the salt out of there. So the ability of a substance to dissolve, or the temperature that it evaporates or freezes, etc. These are all physical changes and physical properties. Here are some other examples. The color, its state, whether it can magnetize or not, its conductivity, etc. Physical properties. Whereas chemical describes how reactive the substance is, and a chemical property is not reversible. Once we observe what has happened to it, it's hard to get the substance back. We've basically altered the substance so much that you've made something new. So what are some examples that we've seen? A chemical property, heat or light, is given off or absorbed. A distinct color change, a gas is given off, or a new solid forms, which is called a precipitate. So here are some other examples of chemical properties. Its ability to burn, we call that combustion. The temperature it needs to start a flame, how it behaves or reacts in air. For example, does it tarnish? Its reactivity with water and acid, how it behaves with certain amount of heat. Keep in mind this doesn't mean change of state. And some examples of color change, etc. So we did this change in class long ago, where we took phenol red and water, and we observed that to be simply just a physical change because we still had red and water. But then we added calcium chloride to it, and it started to heat up like a hot pack. So when this happened, it was C for chemical. And then we added baking soda, and it started to bubble. And gas was being given off, so that was chemical. This one was just physical because we just dissolved something. So it was just P for physical. And then we shook it, which was just a physical change. So let's see how good we are at classifying whether something is chemical or physical. If we break glass on the floor, that would be physical, because if you took all the glass, melted it down, and cooled it, you could get the glass back. Hammering wood, same idea, physical. Rusting, you cannot, once a metal has been rusted, you cannot get that metal back. Rusting is a chemical change. Melting of butter, once you see keywords like melting, you should think physical change, because that's just a physical property. Freezing. Upon first sight, when you see freezing, that's like melting, but what happens, bananas actually turn black and they undergo a distinct color change that we cannot get back. And so this is a unique one due to the chemical altering of the banana when it's frozen. Spoiled food involves bacteria. So just back to this one. Originally, like I said, when you see freezing, you're thinking that's a physical change, but not in this case because the banana turns black. So that's a chemical change. Spoiling of food is chemical. Burning toast is chemical. You can't get the toast back. Making salt water for your sore throat, that's dissolving. Dissolving is a physical process. Bleaching your hair white, that's chemical. frying an egg is also chemical because you've altered the egg and there's no way you can get it back. So I want to talk about what happens between the ingredients, which are the reactants, and the products when they undergo a chemical change. So let's say we have two ingredients and their masses are 5 grams and the other one was 10 grams. And so if you remember in class we had steel wool and we reacted it with a blue liquid called copper sulfate, CuSO4. And we got two new products. One was rust and the other was, or one was copper, sorry, and the other was iron sulfate. And we weighed the products and we found out that they were 15 grams. And so what we should have noticed is, regardless of the fact that we made new substances, which is indicative of a chemical change, the masses stay the same because all we're doing when we react things is we're rearranging the atoms. So we're not making more atoms, we're just rearranging them into different bonding, different compounds, etc. So the mass will always stay the same between the reactants and the products. Here's an example. This is a combustion reaction. It's a chemical change. So we take methane, maybe 0.5 or 5.2 grams. We don't know how much oxygen, but we did measure how much carbon dioxide gas and we measured how much water. So it's a chemical change because you've made two new products. According to the law of conservation of mass, the mass of these two reactants here, this plus this, must equal the mass of the product. So this total here is 6.6 grams. So this side has to equal 6.6. So what must this be for this whole thing to equal 6.6? 1.4 plus 5.2 equals 6.6. So law of conservation of mass, when we react things to rearrange their atoms chemically, the mass of the atoms on the reactant side will always equal the mass of the product. Keep in mind it has to be a closed system, so when we do this, there needs to be a lid on top of it. If we did this reaction and there was no lid, the CO2 gas would escape and you would find out that the mass of the products would be less than the mass of the reactants. So when we put a lid on it or when we react things, it has to be a closed system so that nothing escapes. And that's my lesson on matter.